Okay, welcome back. It's Unit 6, Day 3. So go ahead and cross out your notes and make those 6-3. It is our last instructional day of the semester. So new thing we're teaching you. Okay, today we're focusing on factoring by chunking or by grouping. Now those sound funny, but sometimes we need to do it in different methods. So let's take a look here at some things we've factored in the past. First thing you always want to do anytime you're trying to attempt a factor is factor out any common terms, your greatest common factor. In this case, we have 3 goes into everything and every term has an x. So if I factor out a 3x, so I'm dividing each term by 3x, what do I have left here? So 3x cubed divided by 3x is x squared. 33x squared divided by the 3x that I'm pulling out gives me 11x. And finally, a negative 36x divided by 3x, I'm left with a negative 12. Now we know we're probably not done at this point. So if you remember back to our quadratic unit, we want to see if we can factor this quadratic term. So we're going to look for things that multiply to give us a times c. So multiply to give us a negative 12, but add to a positive 11. So in this case, we know that my factors, I'll write them over here. We've got a 1 and a 12. We could have 3 and 4, 2 and 6. And they have to multiply to a negative, so we need to make one of each pair negative. Negative 1, positive 12 will add to give me a positive 11, so those are my values. I don't have to put this into my box. Well, I guess we should put it in the box. So if we were to put this into the box, we would have x squared minus 1x plus 11 plus 12x minus 12, and here we would factor them out. Top row gives us an x, bottom row, that is a 12. Can't tell, it's a 12x and a negative 12. So we factor out a positive 12. First column I factor out an x, second column I factor out a negative 1. So my factors for x squared plus 11x minus 12 are x minus 1 and x plus 12. So here are my factors for that cubic function we started with, our cubic expression. Okay, so let's take a look at another example. 5x to the 4th plus 20x to the 3rd plus 20x squared. So again, we're looking for our greatest common factor when we start this. Let's see, 5, 20, and 20. So 5 will go in. We have x to the 4th, to the 3rd, and squared. So 5x squared is my common term. So I'm factoring out a 5x squared out of every term. 5x to the 4th divided by 5x squared will leave me with an x squared. 20x to the 3rd power divided by 5x squared. 20 divided by 5 is 4, and x cubed divided by x squared is x. And 20x squared divided by 5x squared is 4. Okay, and again, we want to look at this quadratic term. Can we factor it any further? We always want to ask that. In this case, we need things that multiply to give me 1 times 4 is 4, and add together to give me 4. Okay, so we know 2 and 2. They'll multiply to give us 4, but they also add to give us 4. So my factors here are 5x squared, x plus 2, and x plus 2. Okay, typically we would not leave it like that. Because this is just duplicated, we could rewrite it as 5x squared and x plus 2 squared. So that would be your final answer of fully factoring that polynomial expression. Okay, so sometimes it's fairly straightforward to factor, but other times it's not. So let's take a look here. So this is what's going to be called the chunking method of factoring. And what it means is that in this case, sometimes there's nothing you can factor out. There's no greatest common factor. So when that occurs, we're going to look at this and say, what, if we look at two terms, typically the first two terms, is there anything in common in those two terms? So with 9x squared and 21x, they both have a 3x in them. So what we're going to do is we're going to replace this, and we're going to say let z equal 3x. Okay? So if z is 3x, then 9x squared is really just 3x times 3x, which we can replace as z squared. 21x is really 3x times 7. So I'm going to call that 7z. That's not going to be so easy to distinguish. And we still will leave that as 10. So now instead of having this 9 at the front that's kind of messy, I have just a z squared, so a coefficient with 1. And we want to see, can we factor this easily? Well, sure. We need things that multiply to give us 10, but add to 7. So go ahead and let's go ahead and multiply or factor this out. So our factors are 5 and 2, 5 and 2. So this factors into z plus 5 and z plus 2. So once we finish that, we've got our two factors. We're now going to replace z with a 3x. So instead of z, I put in my 3x plus 5, and I have 3x plus 2. So there I have my factors of the 9x squared expression.